Okay, so basically, I want to give you a chance to do a problem without a perfect grid given to you, just a generic diagram. So a bird flies 7.3 meters west. Okay, pencils, anyone, or everyone's good? Okay, so a bird flies 7.3 meters west, followed by 16.4 meters south, and then finally 18.5 meters east. What's the specific situation in all of them? 3, 7.30, 16.4, 18.5. By sketching a rough diagram, no more grid, just a what? Just a rough diagram, not to scale. You help visualize the problem, calculate the full what? The overall what? This displacement. Is it a scalar or a vector displacement? Displacement. It's a what? It's no. It's a vector, which means you have to give me how many pieces of information? Two. How long it is and which what? What's the what's the angle or direction? Okay, let's do this one together. I wanted to assign it yesterday as a practice, but you already have enough. So let's do this one. Okay. So in general, by the way, in general, I'm not gonna provide you this diagram. You have to provide it. So what's the first direction? What was the first direction? Which way? No, west. Okay. So again, unless I tell you go with a like a different compass, you always go with the usual one. Right is east, west, north, south. Okay. How long is this distance? Okay, 7.3. And then they go what? Or it goes what? South. How long? 16.4. And then uh, 18.5. Now, where is my start? Which point is my start? Where is it? Where is my start? Right here. And where's my end? Right here. You always connect what to what? Start to end. That's why you always label this one and this one. Because some people sometimes, connect these two. Is there a point of connecting these two? No, unless the bird actually stops here, then fine, that becomes the end. So we have to what? Connect this one, and we use what kind of a line? Solid or dashed? Because it didn't really happen in the actual, in real life. So, okay. How many triangles can you always use whenever you want to do what? Right triangle trigonometry, sorry, right triangle stuff? Two, either the upright one or the flipped one. Doesn't really matter. What matters is, like the hypothetical I discussed using Eric yesterday, is that your answers are going to look different, but are they still going to be correct? Yep, correct and consistent, and everything is 100% correct. Okay? All right. So uh, if you use this triangle, where is your angle? It's always the top one at the start. So this theta, whatever it is. Okay? If you choose this angle, sorry, I mean, if you choose this triangle, where is the angle as well? It's also at the top, but it's not this one because it's not even contained. It's the, again, what was the name of an angle that adds another one to 90? Complementary. So you need always the complementary angle if you use the other triangle. So if you do this triangle, you're going to go which way first? East and then south. If you do the other one, you just what? You just flip, but you're going to use the what? The other triangle, the other angle sandwich between them. Okay? All right. Okay, go ahead. I want you to do this problem. Come on. So you have the next slide next to it with the lines. So go ahead. So obviously, what do you need with each triangle? You need this distance and this distance. How long is this one? That one is parallel to this one, so it's 16.4. How would you know this one? You exactly. You know that this whole thing is 18.5. This much is 7.3. So you just need to what? Subtract it. Come on. So this is 16.4 meters. And what's 18.5 minus 7.3? 11.2. Again, whether it's correct or not to scale, we don't care as long as we have a diagram. Okay, so we need to do what first? By the way, can you do trigonometry first? Can you actually find the angle first? What do you think? What did we find yesterday first? Did we find the angle or the length first? Does it matter which one you find first? Do you have enough information to find the angle? Yeah, you do. Because are you ever going to use sine or cosine? No, you're always going to use what? Tangent, because it's the most exact. You already have enough information for tangent. Yeah, you always will have the opposite and the adjacent. But it's always customary to find what first? Length. Always find the hypotenuse first. because technically it is the first piece of information you give in the question. Sorry, in the answer. Okay, so I don't think I have another slide next to this, so I'm just gonna do it on this slideshow. Okay, so I'm gonna do it up here. So c squared equal a squared plus b squared, which is I'm gonna choose a to be this. So 16.4 squared plus 11.2 squared, which is um, calculators are here, everyone, if anyone needs one. Okay, 16.4 squared, where is it? Plus 11.2 squared equals, I got 394.4. 394.4. Is this my distance? Absolutely not. Way too big, even if you compare it to the numbers. Okay, so it needs to be what? It's already squared, so we need to cancel the square or reverse it or inverse it by square rooting it. So c is equal to the square root of this guy, which is going to be very close to 20, because this is almost 400. 19.85 stuff. What's the sig situation? 3. So 19.9. So the distance that the bird traveled as a, sorry, the displacement, not the distance. 19.9 in what unit? Meter. Okay, got that one done. What do you do next? So we do the what? We do the tangent. So let me choose. Let me choose a different color. Let's choose purple right here. So I'm gonna do the triangle, the blue triangle. So tangent of theta. By the way, some people like to put the theta in a bracket because it's technically an input like f of x. It's up to you. Equals. Now, what's the opposite to the blue theta? The opposite to the blue theta, because it would be different if we're considering the red theta. Yep, exactly. It's in its face or across from it, right here in front of it, 11.2, and the adjacent is just the 16.4. So 11.2 over 16.4, which means theta is going to be the tangent inverse of whatever this fraction is. 11.2 divide 16.4. All right. So 11.2 divided by 16.4. I'm going to keep as many decimals as I want here. And then just what? What do I do? Do I tan or shift tan? Shift, because you're trying to go, or second tan, depends on your calculator, because you're trying to go backwards. So I need to make sure I'm in degrees. Yep. So tan. How many people got 34 degrees? Yep. Or 34.33. So up to 3 sig figs is 34.3. So 34.3 degrees. So what's the final answer? Can someone tell me what's the final statement for displacement? Just raise your hand if you'd like to say it. Anyone? What's the final statement for displacement? Like if I want to write the final answer, I would write delta D like this. Delta D equals, what do I start with? Yeah, Hamid, go ahead. 19.9. 1 second, let me see the dot. 19.9 meters, square bracket. Okay. Yeah, which direction did you go first in the blue triangle? Yes, you went down, so straight south, and then east. And what do you put in between? Or yeah, so east. Sorry, not east. Sorry, south. I mean south, east, 34.3. Done. So let's go to the next slide. Okay. Now we're gonna do the first what? New worksheet of today, which now displacement will be what? Will be Angled means what? They're not what at? They're not at 90 degrees, okay? So we're going to, by the way, if a triangle is not 90 degrees, if it's not a right triangle, does Pythagorean theorem work? No, because C always stands for what? C in Pythagorean theorem always stands for what? Hypotenuse. By the way, what are the two? How do you define the hypotenuse? It's always the what? See, okay, the problem is if you always define the hypotenuse as the what? As the longest side in any triangle, is that the only property it has? No, because some right triangles also have a what? Sorry, some non-right triangles also have a what? And a longest side. But what's the feature for a hypotenuse that no other right triangle, sorry, no other triangle has? It's exactly in front of the what? Of the 90 degrees. So if you don't have a 90 degrees, you what? You forfeit one of the conditions for being a hypotenuse. That's the whole idea. Also, why can't SOHCAHTOA work for non-right triangles? Because what does H stand for in SOHCAHTOA? If you don't have hypotenuse, you don't have a SOHCAHTOA. That's the whole idea. Okay? So that's our worksheet for the first worksheet. So there are always two methods, everyone. There are always two methods to do what? Any angled triangle. I'm going to teach you the easier method now. I'm going to teach you the other method, which actually happens to be the official one for university physics. Okay? But we have to do the easy one first. This method, I like to call it the what? Because it always starts with what? Cosine law. But here's the thing. You're not just using the cosine law. At the end of it, you're going to use the what also? The sine law. But because you start with the what? I like to call the what? The cosine law method. Okay, you cannot start with the sine law in this one. I will teach you why. How many people, by the way, remember vaguely at least taken the sine law and the cosine law? I will teach you today the easiest way to actually understand and apply both of them. Okay, so I need someone to read the problem. Let's go with Eric. Go ahead. Everyone, listen carefully. Go. Perfect. One second. Okay. So it flies first east, and then it turns into which direction, Eric? Everyone? No. Okay. But with how many degrees? So if you say north first, you have to what? North, and then how many degrees do you deflect? 60. Which way? East, which means to you it's to the right. So tell me when to stop, roughly. This is about how much? So that means what? The plane moves this way, and then what? Moves this way. How much does it move along this line? The second distance, what is it? 50. So it goes 65, 50. Okay, keep going. Mhm. Before landing, okay. Okay, all right, here it is. So it goes, everyone, eyes on the screen. And then it turns what? Whatever north 60 is, it's going to go along that line. Oh, wait, is it, sorry, is it east 60 north or north 60 east? Oh, east 60, sorry, I heard it north 60 east. So it's east first, and then what? You deflect up, right? East 60 towards the north, okay? So east 60 north. So actually that's why, yeah. So this angle right here is how much? 60, which makes sense. It's a big angle. Okay, and now how are you gonna sketch 50 kilometers here? Can someone tell me how? What's a easy and smart way? How can you know how long 50 kilometers is? Yes, on the axis itself. So everyone, do your angle first and then measure on your paper whatever 50 is from here to here and just copy it here. Go ahead. Say again? But that's the problem. It's tilted. You can't just say 50 here because 50 here is not the same when it's 50 tilted. Okay, so it's easier to use what? Easier to use the 50. And to actually to Ammar's point, you're right. The problem with the two y-axes is that they're what? They're not scaled the same way, right? They should be, or maybe they are. Actually, they are. Sorry, they're not on my screen. The screen squishes. Projector, by the way, always know projector screens always squish because they're 16:9 or 4:3 aspect ratio. Okay, come on. What do we do with this? By the way, do we have a finished triangle yet? What do we do now? We connect the beginning all the way to the end. In a what kind of a line? In a dashed or a dotted or a cut line. All right. So there we go. Right here. How big is this angle? Obviously. No, this one. What's the proof? It's no, because any line goes 180 just like a protractor does. Okay. Okay. Does anyone remember the statement of the cosine law? Just raise your hand if you know it. I can give you a very easy way to always remember it. Never forget the statement. Raise your hand if you know it. Okay, everyone. Here's the easiest way to what? To know the cosine law. Pencils down, everyone. What's the Pythagorean theorem? No tricks. What's the Pythagorean theorem? C squared equals a squared plus b squared. Can I apply this to that? No, you can't because there's no hypotenuse, and C is by default the hypotenuse. So that means what? This needs to be what? This needs to stay the same or needs to be tweaked? It needs to be tweaked. This is how we tweak it. What's the first thing we add to this equation? A what? A minus sign. You always add a minus sign. Oh, sorry, not add a minus sign, put a minus sign. So minus. Does anyone remember what's the next thing we add to this? Yes, Amar? Not quite. The cosine C is at the end. Because it's cosine law, you're going to add a cosine. But what do you add immediately after the minus? You add what? 2. You add 2. Okay, next. What do I have here? A. You put it here. What do you have here? You put it. By the way, do you put them squared or not squared? Not squared. You already squared them once. So A, B. And it's called the what law? Cosine. So what do I need to add to this? A cosine. But a cosine of what? Cosine of A, capital A, cosine of capital B, or cosine of capital C? Cosine of capital of the first thing you started with. So cosine of C. So do you see now why there are 3 copies of the cosine law? What if I start with A squared here? How do I finish? See, once you know how you start, you know there's only one way to finish. Ali, go ahead. If you start with A squared, keep going. B squared, C squared, BC. There you go. Is it making sense now? That's it. So always imagine you're starting with the what? With the Pythagorean, and then you tweak it a little bit. Okay. So, okay, go ahead. And so now copy this triangle where, everyone, copy this triangle. Can I just use your, I'll just use everyone, right here. Right here. Okay. By the way, since you already have an exact version of it, whatever you copy here does not have to be 100% exact. Just a rough schematic diagram. Okay. By the way, what's the first step you do, not just in triangles, but in geometry in general? What do you always do to any shape? What's the first step you always do to any shape in geometry? Most of the time. Say again? You label it. So you need what? You need A, B, C. So first of all, randomly, let's call A, B, C. All right? This is how I'm going to go with. Does anyone know once you name the, by the way, what do you call the corners of a triangle? Or the sharp corners of any polygon in general? Say again? Vertex. So these are the vertices. Does anyone know how we label the sides once we know how the vertices have been labeled? Ammar? Everyone remember, in math, always the corners are capital and the sides are what? Small, 100% of the time. This is how all the equations are written. So A gives this one, sorry, makes this one become small a, small b, small c. Okay. Which one of those three sides am I trying to find first? A, B, or C? Which one of them do I not know? I don't know the B. So that means what? It's a good thing now that we just trained ourselves to write the cosine law, because now I can write the cosine law starting with what? Starting with B or B squared. Okay, so let's write. So who can tell me what the B squared will be? Anyone? We're using the generic ABC. So how would the, okay, Ahmed, B squared equals, keep going, plus C squared, yes. Uh-huh, uh-huh. AC, no, cosine of the very first thing you started with, which is B. Uppercase B or smaller case B? Upper, because there's no such thing as a what? As an angle with a small. It's always the what? Cosine of the capital letters. All right? There we go. B squared equals. So that's still your part B of the question. B squared equals A squared plus C squared minus 2AC cosine of capital B. And then you just plug things in. Go ahead. 50 squared, 65 squared minus 250, 65 cosine of 120. What's 50 squared? 50 squared, come on. 2500. 65 squared. 65 squared is 4250. 4250. And then what's 2 times 50? 100 times 65 is 6500. And cosine of 120, positive or negative? Negative. So this is going to be negative times a what? There you go. That's why it's going to be a plus. By the way, everyone, look at B. Is B longer than both A and C? Not combined, individually. If you got negative and positive here, and you took the square root of B, you're going to find out that B is what? Smaller. Does it make sense according to the diagram? I don't care how bad the diagram looks. Because it's 120, it has to be what? It has to be what? The longest, which means what? Its square root needs to be bigger than 65 and bigger than what? Than 50. Okay, so that's your logical check. Trust me, everything connects together at the end of the day. All right. Um, go ahead, finish the calculation. Where's my pencil? Oh, there. Okay. So the answer is. The answer is. By the way, absolutely no decimals. Do you know why? Because cosine of 120 is exactly how much? Come on, go ahead, plug in cosine 120, and make sure you are in degrees. Because if you are on radians or GRAD, the other measure, you're not gonna get negative 0.5. How many people got negative 0.5? So negative 0.5 is a what? Is a perfect finite decimal. That's why the answer cleaned up very beautifully. However, is this your final answer? No. What needs to be done with it? It needs to be square rooted. Well, sadly, 9975 does not have a what? A clean square root or a whole number square root. But who cares? We always know how to round and do sig figs. So done. So that means what? The displacement magnitude, just the magnitude, 50% of the game. Just the magnitude of the what? Of the displacement or the length of that dashed line is how long? How long? Up to 3 sig figs. 99.9. And was it kilometers or miles? Kilometers. Done. That's it for the what? That's it for the length of this. Which angle are you always going to give me? The end or the start? Where is the start vertex? C, B, or A? There we go. So we are going to focus on this guy now. All right. All right. To determine the start angle A, apply the what? Okay. Let's go do it. And now it's part C. Come on. Okay. So I'm going to just write, by the way, since I know which two fractions to use, do I have to write all three of them? Nope. You can start and then show me which one is useless, but you can jump straight ahead to the one you need. So sine A over A equals sine B over B. All right. Do I know sine? By the way, do I know angle A? I'm trying to find it. So if I don't know A, I also don't know sine of A. So you just keep calling it sine of A. So sine A over, what's A? Small, 50 kilometers equals sine of B, which is what? 120 divided by what? How much is B? How much? 99.9. By the way, can you cross multiply now? You can. Can you just do the numbers and then cross multiply? Yeah. By the way, cross multiplication is going to happen either now or at the end. All right. So let's actually get the numbers done. So sine A stays, 50 stays. Now what's sine of 120? Sadly, it's not as clean cut as what as just 0.5, like the cosine of 120. Root 3 over 2 if you do the cast rule. But if you just do it as decimals, it's 0.8660. By the way, just so you know, whenever I use sine values in math or physics, I like to do it up to how many decimals? How many? I always like to keep it to 4 because usually our last sig fig situation is usually what? 3 or 2. So if you go to 4 in the middle steps, you are making sure that your error does not get touched into the second or the third digit until the very end. So it's point what? 8,6,6,0 over what? 99.9. Now can I cross multiply? What do you think? Yeah, I actually have no other step to do but cross multiplying. I mean, those fractions have to be eliminated at some point. So you cross. So what do we get? We get 99.9 sine A, as if it's a variable by itself, equals, can someone tell me what's 50 times 0.8660? Well, that's actually 433, right? Because it's got like 100, but then you divide by 2. So, if it's 100, yeah, it's 433, right? Yep. Four. Say it. Up to those four digits, I would only get 43.3. Okay. What do I do with this equation now? How do I solve this? Don't think too much. Forget that it's a sine A. What if it's just an x? What if it's just a 99x? Sorry, 99.9x equals 433. Wait a minute. Something here doesn't make sense. Yeah. Oh, sorry. I thought you said 433.33. By the way, pencils down. Do you know how I knew that I made a mistake? Can you ever get a sine or a cosine bigger than 1? Does anyone know why? I went here, I was like, wait a minute. If I divide 433 by 99.9, am I going to get less than 1 or more than 1? Why can you never get, ever? I don't care whatever math you do in your life with engineering, science, or whatever. Why can you not ever get a sine or a cosine, not a tan, a sine or a cosine bigger than 1? What is the original definition from trigonometry of sine or cosine? What's sine from SOHCAHTOA? Opposite over. Which one is always longer? So if you divide the opposite by hypotenuse, could you ever get bigger than 1? No. Okay, everyone, if you ever get a sine or a cosine bigger than 1, you are telling me you are able to build the right triangle where the opposite is longer than the hypotenuse. But what's the main feature of a hypotenuse? It's always the what? Longest, which means what? Everything else is what? Is smaller than it. Does it make sense? Same thing with the what? With the cosine. What's the definition of cosine? SOHCAHTOA. What's the definition of cosine? Adjacent over hypotenuse. Again, the adjacent is less than. Is it making sense now? That's why if you ever do sine inverse of a bigger than 1 number, what does it give you? It's like you're trying to get a square root of a negative number. Can you ever get a square root of a negative number? Is there a square root of a negative number? No, it gives you invalid input or math error. It's the same thing with sine inverse or cosine inverse of a bigger than 1. That's how I knew I was on the wrong track. So it's actually 43 point what? Which is less than 99.9. All right? Again, it will all come together at some point. Okay, so sine A equals what? 43.3 divided by 99.9. Can someone give me this decimal? It has to be a decimal. What is that? It's it's less than half. I know, point 0.4 something. Point 0.4. Yeah, because we're almost dividing by what? By 100, right? So 0.433. What do I do with that number to find the angle? This is my ratio. This is my decimal. Ammar, you do the inverse exactly. So A equals sine inverse of this decimal guy. Okay, how big is it? All I know is that since this one is obtuse, both of those have to be acute, like sharp ones. How much are we getting? I think it was like 20 something from last year. 25.66. However, all of our sig figs are threes. So 25.66 will be rounded to what? If I want to keep only three sig figs, or in this case, only one decimal, 7. Thank you. Oops, sorry. How many people now are feeling more confident with both the cosine law and the sine law? That's the whole idea. You always can think very quickly if it applies or not, and then just quickly how to actually what apply the numbers. Okay? We're not fully done yet. We're almost 95% done. We only have one last step to do. What's the very last step? I never ask you for therefore statements, but at least I need the last step. Ammar? Okay. So how to write the displacement when you don't have a right triangle? Okay, you start the same way. Delta D equals 99.9 kilometers. And you still open your what? Your 2 square brackets. Okay? Okay, everyone, pencils down for 30 seconds. Just focus with me here. How am I going to express this angle, which is 25.7? Easy. Which way do you move first? East. And then did you go down or up? So you went in the which direction? There you go. So it's east. How many degrees north? 25.7. So even if what? Even if it's not a perfect what? Even if it's not a perfect 90 degrees, that's fine. Just choose one direction to move on first, and then tell me into which other direction did you what? Did you turn or deflect? So that means it is east first. It is east first, and then you move this way. By the way, feel free to do this. East, and then you move up. So east, and then you move north. So east, and you move north. 1 second, yep. Go ahead, yep. Ayat, please. Sure.